Hi man, Drums Wrong and welcome to the Back Office Teardown Lab. If you recall from a previous video, I was talking about these joystick interface boards I've made, which are super configurable. And something arrived in the post, and I'm going to show that to you. It's come all the way from China, of all places. And it purports to be the solution to many a problem we might have. There you go, in a little teeny box. And I've been looking for something to test this with, and I'm sort of trying to accrue the parts. This looks like a jolly nice thing indeed. I don't know how much, I think it was the best part of a tenner, but look at that. Oh my word, this is weighted. Look at this. Right, so this is an industrial styly joystick, and oh my bloody hell. Sorry about getting so excited about this, but I just want to show you something. I didn't even realise this. So not only do you have an X and a Y axis, right? That's those two pots that we're going to hook up to this, yeah? You've also got this button on the top, which is, nice, micro switch. Ooh, yeah. That actually works. Damn it, that works really well. It's because you're cupping the joystick. I like that. Precision. But look at this. Rotational. That's, I was just wondering why you had so many wires from it, and that's clearly why it is. So that is one analog input, two analog inputs, three analog inputs, and a fourth digital input will do. So we can definitely wire that up. I'm just looking at these wires. Let's have a look at them in case we should probe them. Let's see what we've got here. I'm expecting two for the shooter. Two for the shooter, two for the shoe. And I don't see a rating on those pots, but you know, they're going to be whatever they're going to be. 1000K, 100K. We don't really care. We can support it because we're just measuring the we're measuring that brush swipping, and if we need to augment it, we can. So my guess is as good as yours, really, isn't it, on this? We've got to put ourselves in continuity mode. Just grab a couple of wires. I'm going to go for the two, I think the two yellow ones, right? Because it's just going to be a simple circuit. So let's go for two yellows. Nice thin wires, actually. Good for mounting. Oh, no, you didn't. That's the two wires there. And then I'm going to pull these three out here. I can't remember the nomenclature, but I would suggest that the white is the brush, you know, the middle, the swiper, the wiper, or the windscreen swiper. You let me know what they're called, by the way, if you know. But I'm going to just make a circuit between the white. You want to be the white on either end. So if we go to the between white and red, we should see will be the same as white and black in the neutral position. So you've got 9.8K, 5.2, okay, whatever it happens to be. How do I do this? I saw it change. I saw it change. Anyway, that'll work. That'll work. I'm just going to turn on the soldering iron. Let's hook this up. Right. Get all the gubbins off. We're going to have to add extra wires too. Do you think maybe I should find a nice box to put this in? Because it looks like you need... How do you even mount that? Oh, I see. You just mount it... What? I admit it's probably a bit obvious now for you guys at home, but what you do is you make a hole that's just slightly bigger than this, and then you mount this collet through, and it's supposed to screw through from here into that base, because that joystick doesn't need anything else, just a firm compression on that. They don't supply the appropriate length screws, and I certainly don't have anything like that. So I'd probably drive just some massive self-tappers down there, some dirty ass self-tappers instead of some countersunk tops. But I kind of feel this needs a box, so I've been searching around the back office for a suitable box, and I didn't come up with one. I just came up with this. It'll do the job, absolutely. It's not going to go anywhere as well if we fill the bottom full a bunch of potting. This will be a heavy item. and not a very pretty one either. So it's ticking a lot of boxes, ticking a lot of negative boxes. But there is something else. I thought if we're going to go do this, let's max this bad boy out and grab into it a bunch of other stuff. So if we're going to make the ultimate controller, I think we need to add all of the ultimate parts. So what we got here, let's work this out. You've basically got, let's count these pins on this bad boy so I can remember what they do. So let's go through them. You've got V in, ground, 5 volts out, that's fine. And then you've got basically an analog. And then you've got a digital input. And then you've got another analog. And then we jump across here. I think RC3 is a digital. Analog, 1, 2, 3, 4, 5, 6 analogs. A. Let's count this. 6, 7, 8, 9, 10. That is correct. That's what we're going to be hooking up there. So if we take this joystick, you've got up, down, left, right, and fire. That's those taken care of. Nice. You've also got yaw. Then that's going to be your yaw. So that's going to be the X, Y, and fire can be on those. You've got yaw. What else? We've got spare fire button. So that's fine. We've got toggle. Ah, beautiful. Look at that. Momentary. Bang. Give me some chaff. That's going to be fine for that. We can put that on a momentary on the thing. We've got a momentary switch. And that leaves us with 1, 2, 3, 4, 5. 5 more analog things. So what we can have is there's a variety here. We can either use some of these joysticks, which you've seen on kind of model airplane. You've got this one which is kind of fixed like a throttle, which is nice. It's not sprung. And then you've got this one which is center sprung. So I kind of think if we've got a video game, this one could be kind of cool too for an additional like vectoring, you know, think of it Elite Dangerous. So that's another 2 analogs. So we've got X2 and Y2, and then we've got 3 more analogs left. And do we? Yes, we do. 3 analog pots. Boom. Pot, pot, pot. That's a pretty good setup. So I'm going to clear this away a little bit and just start drawing on this box. Let's see a suitable layout we might want to use. Clearly I'm full of crap. They do have the screws in the packaging. Nice one, guys. For like under a tenner. Nice one. There you go. After much planning, which is 0 planning, I basically decided I'm going to pop on like this, because this kind of makes sense. You got your joystick here, and there's enough thumb rest here that you've got a decent amount, but you don't want it too far inboard that your wrist is hitting. You want it too far out that you're just kind of waggling it on the end there. Your palm can hit there, and this is okay. You know, this is like you could turn out with your fingers. I'm going to mount these 3 here. Remember that although these are rotary, so you could use them for trims and stuff, you can also configure in the software that they're just like act as a digital. So you could basically say anything on that, once it goes over a certain threshold, on that one it's on. Once it goes under a certain threshold, it's off. You can set the dead zone. This could be for undercarriage, anything as well, right? So you don't actually have to have this as a an analog object in the game that you're trying to operate. So literally, if you just want undercarriage down, undercarriage up, undercarriage down, carriage goes down, carriage goes up. Okay, you got it. So just punch some bloody holes in this box, because all I want to do is get it wired up. Measure once, cut twice is what I always say. So let's have a look here. Measuring. Ooh, let's measure that down a bit. Measure that in a bit. Measure that up a bit. That is pretty perfect. And you can see I'm just marking on the plastic. I'm going to go balls to the wall on this. We do not want this part. Yeah, that's fine on that one. So I guess if that's going to go there, we kind of want this one. It's kind of cramped if you're going to put them that close together. Or do you want that just there? And some knobs here. Knob Creek. I don't know, I think that's kind of cool actually. It's a little bit offset, isn't it? Because you're like trying to do this. This is more of an adjustment thing. What is it? Yeah. You need to make a hole now. Kinda almost this diameter, but a bit smaller. So almost this diameter, but a bit smaller. Or just make it this diameter. Do the inside part. There you go. Let's just check that again. That would be insanely large as the hole, by the way. I'll work something out on that one. I think basically you're trying to lose about 6 mil. So that's some slick action right there. Good enough. Hot glue will help immensely. Now we got these guys. We've got, what did we have? Well, let's look at our chart here, our techno chart. 3 of those and a momentary. I'm kind of guessing if I had that there, I would want the momentary. Intergalactic momentary. I'd want the momentary probably like that, so I'm flicking it down. Or do you want to flick it up? No. Flicking it down is definitely a more natural thing. And what's really annoying, I did have a really nice switch somebody gave me. It was Howard Taylor from Dubious Engineering, and I can't find it. So, whatever. So we're going to pop that there. It's going to be around somewhere. It'll turn up immediately after we make this. And then we have 3 more pots to do. And using my measuring eyes, I'm going to go 1, 2, 3. Yes. Okay, let's cut this out. That's the pilot's done. It's time to tap and unwrap. Let's put this in the bin. I have to admit, I've never gone about making one of these this way, using the multi-tool that way, but actually it works pretty good, so I'm fine with it. You can see this is an external IP55 or whatever waterproof mains box. So it's pretty good plastic, made in the EU. And it locks through. It's IP65, pardon my French. And that's actually a really nice box to ruin, but that's fair enough. They're kind of cheap now. So what we're going to do is just drift through these holes. We're ready to go. Just going to drill out these holes. Had to change collets. We can start fitting things now. I should tidy up as I go along, but I'm just going to leave this here for a bit, maybe a week. So I've got some self-tappers here. I'm just going to drive those through. I might have to make the holes a bit bigger. But then again, I might just see if I drive them in and just keep turning, they kind of make their own hole, right? Yeah, there you go. There it goes. Made its own hole. What more do you need? Oh, look at that. Perfect alignment. I never knew why I didn't go into the aviation industry or something. I could put together some 747 MAX cockpits. Do you think that's how it's done? I'm sure aviation engineers take a lot more care than I do, but you never know. I could be a field engineer, just, or you know, like in the military or something, where you just got to make something work. You got to make this work, boy. Just get it going. Get it on. Oh shit! I just drove that into my finger. Yeah. Dishonorable discharge. You leave your dishonorable discharges at home. Oh, that works really well, actually. Almost too well. It feels kind of stiff. I'm kind of thinking I've overcooked something. Let's loosen it a bit. Yeah, it's loose now. Don't over tighten those. Good. Right. Let's take this bad boy. Doesn't really matter which way it goes, but I'm just going to put the wires to the top so we got a little bit more space to play with. It's got very delicate fittings. This is a precision instrument. And I'm just banging it in with nails and bloody hot snot. I like that they've actually given you 5 screws. You've got a spare here. Put that aside to lose when I come to need it. I'll go, yes, there was a spare, but it's gone. Just going to try to get those started through the holes. You can see if my alignment was okay, and it sort of is. Look, they actually sat pretty flat. One more. That's good. That's real good. That'll work. But this is the tricky part. How to get it all sandwiched nicely. Yeah, I'm holding it pretty good there. It's that muck. It's not much on it. I think it's designed for something for much thinner use, like, you know, an X-ray machine or CT scanner or something. Now when I'm doing this, I'm sure I'll push that rubber. I think you're going to have more flex if you push the rubber, because you'll get like a little bit, you're actually compressing it. If you think about it, you're compressing that rubber dust shield thing in there. So give it a bit of welly, a little bit, not too much, but enough. Especially if you've got something thick like this. If it's thin, it probably won't matter. Oh, that looks so good. This is actually, you know, I do make these things like as a joke sometimes a little bit, just as a prototype. I just wanted to see if it will work, but it is actually really nice in its motion. I mean, I could make a metal plate. I've done that before, where I just get a nice metal anodized plate on these boxes and then have it all like laser etched. That would look actually pretty beautiful. I could do that and still can do that. So once you've done this, you get all the dimensions, put that into CAD, get a tin of piece of aluminium with black paint on it, and then just put that in the laser cutter and just get all the, you know, decals done. Holy smokes, that's actually really good. Oh look, you can operate it like that too for precision. Bloody hell, I haven't made something that's good, have I? We don't want to do that. Time to mount all of our knobs. I'm going to cut it out of this other wiring harness. We don't need that. So we've got one. So you can see this one's made out of parts of a harness of an old radio controlled gadget, so that might be good for you too. And sometimes the wiring of the harness actually might work in our favour. So let's see this one. You need the orange and the white of this one. You can take a tap off it. Orange, white, orange, white, yellow and red. So yellow and red will be the going to the power rails, basically the 0 and 5 volts, and those two are two separate inputs. So you don't actually have to rewire it. You can just reuse those if you can. And let's see, pull those. Oh, look at that. That is some nice knob action, isn't it? Have you ever seen something so weird? That's a very, very smooth motion. So yeah, maybe you could just go out and buy some of those radio control things. You might have one, but that's why it's a nice weighted knob, because it literally is a piece of brass. It's even got a little lock screw in there. You could demount it all. This sort of work requires very precise drills. And if you don't have those, one of these. One doesn't look like enough. But let's have a check anyway. You don't want to go too nuts. Number 2, I think. A grade 2. Oh, we're already at grade 2. 6mm then. We're going to 6. And it runs away with you. It can really go quick. You got your whole world in your hand. Oh, that's good. By the way, not all knobs are made equal. There are 2 different sizes here. 2 little ones and 1 big one. I'm going to put the big one next to the switch, so you've got, it's important. And these are 15, was it 15? No, 5K. 5K pots. Get out! These are quite good, because look, the hole is just such that they are almost tapping into the plastic on this thing. So you've got belt and braces here. And just clear that off. Get your cap on. You can keep your cap on. Oh, lovely jubbly. That could be extra fire button. Takes time, doesn't it? It's precision engineering. You can't rush perfection, can you? See, I'm just hot snotting all of the main components here. We're going to get a fresh board here. That fits nice. They are USB devices, so it might be handy to attach the lead while we still can. Let's check that it's possible to do that. We might also... Oh, what idiot chopped that off, muppet? Oh, I don't know. Let's just see how long that is. It's about 1 meter. I could do with a bit longer, but... Will that work? Will that fit? I'll work something out. Oh, I have. That'll do. Now it's time for wiring up. So basically all of these potentiometers have a live and live and neutral, plus and minus, whatever you want to call it. And we're going to work out which one's which. So when you see something like a pot, if you don't know which terminals are which, you can basically probe the wire. So this is the rotation on the joystick. And you can see it says 10K between the white and the red wires just down on my meter there. And as I turn the knob, you can see it's not doing anything. So that's good. It means these two are actually the two end parts of the pot, because if you had the black and the white, or the black and the red, as you turned the knob you'd see that flicking around. So what I'm going to do is common these power rail basically across everything, and I'm reluctant to cut wires on things because I do have an awful habit of retasking the hardware, so I'm just wrapping it around blocks. That's the block that the actual controller is going to go on, but I thought it's handy, it's sitting there doing nothing. And again, if you're doing it at home, you're probably not going to just do what I do and bosh everything in it with hot glue. I just remembered I forgot to tin the wires, so if you want to make life easier for yourself, of course, tin your wires. And these little wires, although they're nice and kind of flexible, they tend to get away from you pretty quick. So you're going to need 3 hands. And if you go on my Amazon web shop thing, and I don't know where the link is, I think it's in the description down below, I did find a set that I really must buy myself, but I've seen friends using and I hear very good things. It's like a modern version of those helping hands you used to get if your gran would buy you a soldering iron kit. Apart from it actually kind of works. So if you want something that semi-works, that's the kit for you. So we're going to keep the black wire out. We decided that's the wire we're going to keep. So we're just, again, hooking up this common power rail. And we're going to have to do the same for all of the pots. So that's the different pots on the joysticks here, and anywhere else we find them. And then the switch too is going to have that. So in the switch, you're going to have a plus and minus, which is either end. So if you've got 3 terminals on your switch, one end is going to be positive, one end is going to be negative, and then the middle is going to be the wire that goes to the input on your board. So we've got a few old wires to attach just yet, but fortunately, if you can see here, this harness is already kind of pre-hooked up on that power rail, and you'll know if you've done any work on jammer boards or arcade joysticks or anything like that, they basically do the same thing. Oh, that's hot. I'm taking a lot of care here to make sure that every single wire I use is a different colour and non-standard to any nomenclature you're used to seeing. So that's where I am now. I'm just hooking up the power rails. I'm just scrounging around my desk because really I don't use this gauge of wire at all. So I'm just cutting bits of wire. But you can do the same, do it properly. You just want to end up though with all of your pots having a main wire, which is the one which is going to have the variable amount of voltage on it. So these ones I've wrapped them around the back. Here you've got a couple of red danglers. I'm going to hook up the power in the middle one of those. Middle part, this purple wire, that's going to be that feed for that one. And we're almost there. It's been a while. I've been stripping wires and I've been basically reclaiming absolutely every piece of wire on this thing. Look at it, it's a thing of beauty. Look at these rat's nests, it's a mess. This switch is all using purple wires. This lot is bundled electrically to that side using the thickest gauge wire I've ever seen in my life, and I've joined a wire here with some very dodgy looking heat shrink that I used a lighter on. So it's pretty much the worst job you could ever do. So I've got my board in. I've actually glued it to the piece of foam by gluing its USB connector on there, which I've actually shaved down with a knife so I can bend the wire around. This is a quality finish, guys. I've put every effort into this to make sure it's perfect. So what I'm going to do is tin all the pads I'm likely to need. And I think with our design, and I use that term very lightly, I've managed to basically reduce all the power rails down to this pair of wires. So that's kind of a convenience for us. So that's nice. So what we're going to do is just start tacking and tinning, and we're going to go from left to right. And I'll zoom in so you can see the pin contacts right there. So we're going to need ground. Clean my iron for a change. We're going to be ground. I mean, these are nice gold contacts here, so it should be okay. Oh, my iron isn't though. Turn up the heat a little bit. What I'd done with this, which was a bit of a no-no, I actually used it for melting some plastic that had been used on those old radio control wires, and that was really a bad idea because it stuck onto the tip of the iron and just oxidized. So skip out pins 7 and 8. They're all numbered 1, 2, 3, 4. Because 7 and 8 is a serial debugging pin, so you can actually monitor what's being sent out via the USB. And you don't really want to mess with that right now. So we're going to skip that. And then on the other end, of course, you've got another V in ground and 5 volts. The reason you've got a V in is that this board does have onboard regulation. So we've got it configured to take its power from the USB port. But you can see there's a little jumper back here, just there where my fingertip is. And you can obviously have a DC jack to give this board more oomph if the gear you're using seems to be sucking out more juice. We can always count the pins. We know we had 10 I/O. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like they're all there. I have in my hand, it's just off screen, our little yeah. I think this is the X. Let's start. This is going to be, this black wire is the X, and I think we decided that was going to be the first analog. So that is, in fact, before we do that, let's hook up the power rails. So we've got a red wire here, and that's going to be going to our 5 volts. And did I tin that red wire? Of course I did. It's up to you. You can obviously solder pin headers. This board's made for pin headers. It's made to work in exactly the way you'd want to work if you were using Veraboard and stuff like that. I'm just soldering directly to it because I'm an animal. Oh look, and that's how good my soldering is. The other actual end fell off in the meantime. So let's go through the process of just quickly finishing a piece of wire properly. And I'm going to blame the factory that did that end. That's a factory end, that is, not my end. Not my quality hand-finished work of art. There we go, and we're all tinned and ready to go again. So I'm just going to solder that to the potentiometer, which I've done. So where were we? So this is the X. So we've got the X wire there, which is on pin 4. I'm just going to hold that there, let that, cool down. And then we have the digital wire, which is this. Remember the yellow, the thin yellow one, which is the digital trigger from the top. Now the other end of that is hooked up to the positive rail of our board. So I can't remember if we've got a weak pull down, a weak pull up, whatever's set configured on this port, but it's okay. What we can do, if you need it's basically going to push 5. When you push the button, 5 volts will be on this pin. But when you let go, if this input is floating, we just put a little resistor between this pin and ground, and that will just bring it down. And you can even, these are ground points here as well on these boards, these 4 gold corners. So you could be able to put a pin across to them and get that resistor, and it's just going to bring it down, no problem at all. So now we have in our chart, we've got the next one, which is X fire Y, that should be. So the next one should be the Y, which would be on pin 3. So we'll just solder that on there. We're already halfway there, sort of, ish. Just hold it there, and we'll work our way through. I'll just zoom out a bit so you get to see some of these things as I'm doing them. And then we have another digital. We had another digital input, and that is this purple wire. And this one's fine because this purple switch, do you remember you had 3 pins on the switch? The center is the one that's going to the board, and then you've got positive and negative. And when you throw the switch, you're either making contact between these two or these two. So it's a very hard 0 or a hard 5. So that's quite good. And I'm hoping I've got these the right way around. It has been known that I get my pins mixed up. So we'll see when I hook it up if all of a sudden the digital the digital on-off is being activated by a pot somewhere, and I'll be okay. So the next one we said was a Y axis, which must be this one here, because this is the pot here that moves this Y axis, and that's over there. And then the next one is Z axis, which is the one that's been extended. I say Z axis. It's Y2, not YZ. Y2. And then what do we need? We need a few more. Am I losing my marbles? Oh, I've done a boo-boo. Let's revisit that. I've done a boo-boo. You know why? We wanted to hook up the yaw. Now we could do this totally in software, so you don't have to worry on these. We could actually reconfigure this in software, but while I'm here with the soldering iron, I might as well just reconfigure it so they're coming in the same group. But if you remember, that little joystick had this little black wire. because you could twist the joystick and it would be able to use that. That'd be quite good if we use this joystick for sort of video editing or anything like that, or really just a flight simulator. So we'll put that yaw wire in there. We're nearly there, guys. We've just got 3 more wires, and those are the 3 pots that remain. So we'll just go untinned, untinned, untinned. Let's just trim those up, and that's how it goes. I mean, it's really a case of preparing everything, isn't it? By the time you've got your wires at this stage, you're practically finished, aren't you? And again, I always advise twisting the wires when you tin them, but I'm just not going to, because I'm just going to rush this a little bit. It doesn't matter, because look at this. I'm not one of these proud people who just care, oh, look at my lovely soldering and wire layout. It's like, okay, is it functionally the same thing? Yes. Is it probably going to last the lifetime of this device? Yeah. So that's probably good enough for me for right now. It's not like I'm selling this on the high street. But there are some people out there who really do a good job of things, and I don't blame them for it. I think that's a good thing to do, but it's not necessary. Just shows you, you don't need all of the skills. So I suppose you do need the skills, but you don't need all the high-endest, the height of the skill. So let's let this focus up. Come on, camera. There you go. That's all the wires in, and you can see all the slots we tinned are filled. So I'm pretty sure this is going to work. So I think I'm just going to put it in the box. I'm not even going to check it. I'm not even going to check it. So you can see I've already got a hole in the box. I've put the USB cable through it. So what you're going to need to do though is work out some strain relief. So for here, which I have none, I do have on the shelf some, what do you call them, cable ties, big old cable ties. And I'm just going to make a guesstimate of where we need to put one. So I'm going to put it right here, and I don't know, this USB wire is already pitifully short where my computer is, so it's going to be painful to even use this, but through my eyeball I think that should work. Let's see, there you go. Okay, that's going to work. I'm going to pop that lid on, and then you've got these screws, which are that's plastic screws, which are awesome. They're just like half turn. Pop them in, and then you just give it a half turn till the alignment thing blocks. And it's compressing that seal, because it's actually more than a half turn, but it's compressing that seal because it's, remember, a waterproof box, and that's what that is. So the box is now sealed. There's your wire. You can put a grommet in there or something like that. And yeah, look, all the pots actually line up. I like that. So all that's left now is to hook it up to the PC and see if it works. I did arse it up a bit actually. I just plugged it in. Mostly worked, but the little joystick didn't, because it's not a dad, it's dada. So I need to reconfigure these wires a bit, and then that will start functioning. So yeah, a little bit of a brain fart there. But yeah, this definitely needs a weak pull down. So I've got a 100k resistor between the fire button on the little joystick thing and ground, which I'm just tacking back in. So just to show you the setup, the joystick is sitting here and it's all hooked up as one would expect. So it's basically the reverse as you would be sitting with it. So this is the top and this is the bottom. So you can see my hands here. So I'm holding it this way. And you can see on the screen there's something called vSerial Feeder. So that's a piece of software that is on GitHub, but I'll make available via the driver stack for this when I release it. Of course, I am open to beta testers now for this PCB. So please ping me on Patreon. If you are a patron, you can get a free one from me if you ping me, if you promise to give it a good test. If not, ping me anyway and we'll work something out. So just to show you all of the controls, so I've configured it, and I'll show you how easy it is to configure this software. Basically, you add buttons and axes and bitmap buttons as you wish, okay? So if I just wanted to add another axis, for example, I could just add it here, and I'll choose the channel on the unit I want, and you can see there's a lot of channels up here, but we only go to channel 10. There is a channel 11, which actually tells you the firmware version of the unit. So you can see we actually do broadcast the firmware. So this is version 1 for you boys and girls at home, but we'll remove this. So you can see I've already added all of these channels. I've called it test profile. And it just goes in order. You saw the way we actually soldered the PCB from pin 1 to pin 10, skipping the 2 RX and TX pins. And that's exactly the same map. So you can see the D, A, D, A. Do you remember the DADA mishap there? And then all of the other analog inputs. So I'm just going to twiddle the joysticks to show you. So we have here channel 2, forward and backwards. And then left and right, that's channel 4. You can see it there, having that effect. And if I twist it, you can see channel 5, okay? And you can assign which axes get translated into the joystick interface through this. So you can see you have a choice here of X, Y, Z, RX, RY, RZ, slider 0, slider 1, and none. And I'll just show you the setup procedure for each channel. I've already done this, but we can do this again. It's quite easy. You hit calibrate, and let's say you're doing this axis now. You can see on the screen it's moving as I do that. I'm going to let it center by itself, yeah? And then I'm going to hit next. And then I move it through the full extents. And that's pretty much all there is to it. Now you can see that's a very linear curve, okay? And if you don't want a linear curve, you can easily adjust that by just changing it here. So you can see you've got this exponent, so you can set up an exponential curve, which I'm just going to hold down, and you can see right there. So that's going to give you, it's going to be very gradual, 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 and then boom, very quick response. So that'd be like a car accelerator where you want, you have a performance chip tune. And let's say you've got a joystick that's a bit crusty in the middle. It might be an old joystick you've done, and it doesn't always center back to where you want, to the 50%. You can actually set a dead band here as well. So it's got this nice flat area. Do you see there? So it doesn't do anything. It doesn't, Windows won't see that. In fact, if I click here, so it'll update the screen, you can see I'm wiggling this left and right a bit. It's not going to be doing nearly as much there. Okay, actually, because I haven't hit OK, duh. Right, so now you see Windows, I'm moving it up and down. You can see the values actually moving in the software, but you can see here, it's not doing anything until I push it right up or right down. So it's got that dead zone right in the middle, which actually we don't need. So I'm going to set the dead zone and the exponent back to 0. And then you've got the digital inputs, which are basically going from a value to 0 to 255 instantly. So they're basically maxing out, which is fine. And you can see, there you go, digital input. And if, for example, you've wired it wrong, you can invert it. So I actually have the light here you see flashing on the screen. That's my toggle there, and I think I do invert that one. Yes, I invert that one because it's actually on all the time, and when I trigger it's off, so that's fine. I invert it, so when you go back into Windows, you see it only comes on in Windows on this left screen when I actually want. So buttons 1 and 2 work. So the joystick, turning it around, that gives you the axes in Windows. So I'm using the Windows joystick calibration tool thing on the left, so watch that one. That's the one we're playing with right now. You won't really need calibrating because you've done it already in your profile. And then you've got the left hand, which is kind of like a throttle really, because it's that's your Y rotation apparently. That's what we've got it set to so far. And then if you move it left and right, you've got X rotation. And then you go, oh, what's Z rotation? Well, remember that big knob up here? That's acting, oh, yes, that is acting as Z rotation. I was thinking a minute, oh, what's Z axis? By the way, you've got Z axis on the screen. That's when you rotate this stick itself. So you can see I'm rotating it. I'm holding it an odd way, so you can see my fingers moving. But yeah, that's actually got a rotate in it. So that's really cool. Can you imagine for like panning video or something? That would be cool. And then you've got the other two knobs here, which one is called slider and one is called dial. And that's basically all the inputs you have at the moment. I did show you once there was one option. I'm going to just add a new bitmaps button, and we'll set it to, what will we set it to? We'll set it to our channel 8, because channel 8 knob is a nice one to show you. So I'm going to set it to channel 8. So you can see channel 8's knob here. And what you can see is as I'm turning up the values, yeah, you're seeing a binary representation filling up, which is kind of groovy, and then it maxes out. That's the maximum of that channel, right? And again, as I said, as I'm turning it down, you can see it's going lower and lower and lower and lower. Now, if you have really clean, defined steps between your analog input, which you can use a resistor ladder, what you can actually do is set these to be additional buttons. So that's button 1, it's saying. Let's set it from button 3. We'll say that's button 3. This one's button 4. This one's button 5. So you've got to be careful. And it's setting it whether or not it's whether it's a rising or falling edge and all of this sort of thing. You know, it's basically like an oscilloscope style trigger, and you may get some success, because if you can run it like that. In fact, let's see what happens here. How do we restart this? Let's save this. I'd like to see it in Windows, to be honest with you. Let's go with that, and we're going to do game controllers. I think we're going to have to go into the VJoy profile. Oh, there you go, configure VJoy. So you'll have to install VJoy, because that's giving you an abstraction layer. And let's see, you can see here number of buttons. I'm going to say number of buttons 10 for argument's sake. You might as well, you could just leave them on some big number really, couldn't you? And you could hear it unplug itself. That's virtually unplugging itself from Windows. And let's have a look here. Do we have the buttons? Yes, look, there you go. You have a whole load of extra buttons there now. So what I'm going to do is I'm going to disconnect our serial feeder from this unit we've just built, and I'll reconnect that to VJoy 1. And hopefully, there we go, everything's working. Now as we turn, do you see that as we turn that knob, that Z-axis knob, you can see those buttons on the screen flishing and flashing away. That's because that's activating those other digital inputs. So they're there for you if you want them. So I'm going to put this back to 2 though, because that's what we have physically on this, so we don't need to get confused. We're configuring all of this so we know how it all works, so that's absolutely fine. And you can see here you've got other things here like the POV hats and some additional stuff here that you can probably hook all of this stuff into, although I don't have a HOTAS set up to test it with. So that's the Whistle Stop Tour. I'm going to fire up a game and we'll see what it does. I'm in Elite Dangerous now. I'm just configuring it. I've given it the generic joystick profile, but I've got to go through. So we're going to click your axis and I'm going to move the twisty thing. It's weird actually. It's like kind of, do we want your on this stick or this stick? It's really entirely up to you. So I'm just going to say at the moment I want your on this, which I have. So it says joystick Z axis is currently bound to throttle axis. Do you want to rebind it? Yes. Definitely confirm that. Roll access. So yeah, roll could be nice on this. Roll and pitch. Pitch. There's no. The thing with pitch is if we use that for pitch, I don't think that's what we want. I think we want roll for this. I think we want pitch for that. It says inverted, non-inverted, so we have to play with this. And let's go for flight thrust. Let's go through it then. So here we go. So we've got thrust left. We could do thrust left minus joy RX. Thrust right plus joy RX. Vertical thrust up. I think we want thrust forward and backwards though to be. Oh, these are like buttons though, aren't they? We might get ourselves in a trouble. Let's just assume we're going to play through some of these. Flight throttle access. We want that to be this big knob here. Then increase throttle, decrease throttle. No, we don't have anything that we want like that, which is just like on a button. Flight landing. There's pitch, roar, yaw, roll, flight miscellaneous, engine boost, toggle frame shift drive, super cruise, hyperspace jump. Now, let's see what it does if you try to assign it to a rotational thing. So we're going to do frame shift drive as this knob here. It does let you choose it, so I don't know when that activates it. You know, it might have a dead zone on that one. Did we use this button? No, I feel we haven't used this. It's set for something in here. It should be for like maybe weapons, shouldn't it? I think we should have that for weapons. So we'll take that off for flight stuff. Is there any combat? Oh my gosh, so many things here. Targeting and weapons, how about that? Primary fire. We'll make this the primary fire, joystick 2, and we'll make this the secondary fire because we want to be focusing on controlling and we'll be shooting with this. But yeah, okay, that's enough for now. Let's just try it. Back to game. Resume. It's been a long time. Whoa. Okay. Oh, look, that's the throttle. That's quite nice as a throttle, though. Right. Oh, this is cool. Getting the hard points deployed. Right now, I'm not sure it's rolling the right way. I think we need to invert the roll axis, but that's fine. The I don't know what you call this. The vertical roll is fine. So that's thrusting left and right would be cool when we get to. Oh, so that's speed 2. So we've got 2 throttles. Oh, I can't wait to try this properly. This is cool. Right, I think I've made my point though, guys, haven't I? I've made my point here. This thing works super well. And if you want to give it a go, again, as I say, if you're a patron, please jump on. Patrons are being given exclusivity in the beta test program to receive a free board. Maybe if you want to help with the PMP, that's awesome too. But if you're not a patron and you still want to be involved, just contact me through my Discord and usual channels. You'll find me, and we can discuss what interesting projects you want to make with it. But there you go. So that's me, Andrew Armstrong, at the back office, signing off. And if you'd like to hear more on this, by the way, hit that bell icon so you can be informed when I make another video on this subject. As ever, thank you for watching.